Alright, welcome to this new video. Focuses on the variations of parameter. And before that, remember in the previous video, I introduced homogeneous differential equation and we were able to solve some example on homogeneous differential equation. Now in these videos, I want us to look at the non-homogeneous differential equation. So the famous method used for this type of equation is called the variations of parameter. So basically, the non-homogeneous equation is given by this type of equation. This is at order n, right? Where the right hand side is given by this function f of x. So it's not longer 0 as in the previous video. The variational approach is useful to solve this non-homogeneous equation, but not only, we can also use this to solve other type of differential equations. In these videos, I will focus on the second order of non-homogeneous differential equation because we can still generalize, go to the third order, fourth order, but it's a bit cumbersome and it's doable, of course. But if you understand the approach for the second order, you should be able to do the third order, the fourth order, and up to order n, okay? So let's consider this equation. This is the general form. At second order, we have a2 times d2 plus a1 times d plus a0. All this multiply y is equal to the function fx. All right. At this stage, the general principles provide you with 5 different steps to follow in order to solve this equation by using the variations of parameter. The first approach consists of considering the left-hand side equals 0. In that case, the equation becomes homogeneous, okay? So first step, we want to solve the homogeneous equation associated to this one. So the homogeneous equation associated to this is a2 d2 plus a1 d1 or d plus a0 times this is equal 0. Of course, this is equivalent to a2 of x plus a1 of x plus a0 of x is equal 0. All right, the non-homogeneous solution here is y0 equal a times y1 plus b times y2. All right, for the second step, we have to find the general solution. So general solution. For the general solution here, we consider that the general solution is y is equal y0 plus yp. Okay, yp is a particular solution. So this is a y1 plus b y2 plus yp. So we are looking for yp, where yp is equal, we introduce new function. We consider that this is u1 of x, y1 plus u2 of x, y2. When we find the derivative of this, yp prime is equal u prime 1 y1 plus y1 u prime 1 plus y2 prime u2 plus y2 u2 y prime 2. So the guys who derived this method names Euler and Lagrange. So Euler and Lagrange assume that the derivative here, this and this are 0. Okay, so let's just take it like this. I can't prove it now, it's out of our interest. So if we take u prime 1 y1 plus u prime 2 y2 is equal 0. Let's consider this as equation star, okay? We will make use of this star later. So if we consider this, then yp prime become u1 y prime 1 plus u2 y prime 2. Of course, we can obtain the second derivative of this. This is y prime p is equal u1 prime y1 prime plus u1 All right, this is what we obtain. Then YP, if we substitute in the general equation, our general equation is given here. We have A2 YP second derivative, okay? This second derivative plus A1 YP prime plus now we know Y prime P and Y prime P. So this is A2 bracket. We write this whole term. This is U prime 1 Y1 plus U1 second derivative for the first derivative we have and for the last term we have A naught U1 Y1 plus U2 Y2. This is equal F. All right, remember that Y1 and Y2 are solution to the homogeneous equation, okay? So let's write this term together. We can write this, and this together. And we can also write this, and this term together. This becomes U1 bracket A1 Y1 plus A1 Y prime 1 plus A0 Y1 U2 A2 Y prime 2 plus A1 Y prime 1 plus A0 U2 plus, so we remain here with this term and this. So this is A2 U prime 1 Y prime 1 plus A2 U prime 2 Y prime 2 is equal F. All right, remember that Y1 and Y2 are solution to the homogeneous equation. So this means this is 0 and this part is also 0. Right, if you take this here, you substitute to this equation, then you obtain exactly 0. That's why we have to set this 0. So we remain with this equation. I can write it in this way. A2 U prime 1 Y prime 1 plus A2 U prime 2 Y prime 2 is equal F. We can first derive this by A2. So this is U prime 1 U prime 2 U prime Y prime 1 if we call this equation star 2 star, then if we combine first 1 star and 2 star, we have the following. So this is what we obtain, okay? And this is equivalent to, you can write this as a matrix. So this is Y1, Y prime 1, Y2, Y prime 2, U1 prime and U2 prime is equal 0 and F over A. All right, let's call this one a matrix M. Okay, let's call this M. So we have the first step, the second step, then the third step consists of solving for U prime 1 and U prime 2. So we solve for U prime 1 and U prime 2, okay, by using the inverse of this matrix. So if you multiply this by the inverse of this matrix, then you obtain U1 prime and U prime 2 by using the inverse, let's say M inverse. So this is the third step. The fourth step, once we obtain U prime 1 and U prime 2, is to integrate U prime 1 and U prime 2. Okay, finally, we write down this general solution. Write down the general solution. So to sum up, when you have a second order non-homogeneous equation, the first step consists of solving the homogeneous equation. And once we solve the homogeneous equation, we obtain the homogeneous solution. The next step consists of using this formula. So you know the homogeneous solution y1 and y2. You solve for y prime 1 and y prime 2. Okay? So you find the matrix M, and the third step consists of solving for y prime 1 and y prime 2. The fourth step consists of integrating y prime 1 and y prime 2 to obtain y1 and y2. And the last step is just to write down the general solution. So in the next video, we are going to solve 2 examples. We just have to apply and follow all these steps. Follow me in the next video. Thank you.